Hey students, in today's video we're going to go through the 8.3 rational numbers lesson. Our learning target today is I can compare and order rational numbers. So first up is some definitions. Integers, fractions, and decimals make up the set of rational numbers. So we learned in our last couple of sections that integers are all of our whole numbers like 0, 1, 2, etc., and also all of their opposites, like -1, -2, etc. So just as a reminder, those are what our integers are. Rational numbers are now going to include fractions and decimals that are both positive and negative. A rational number is a number that can be written as a over b, where a and b are integers and b does not equal 0. This just means a rational number can be written as a fraction or a ratio, right? Rational ratio, where the numerator and denominator are integers. There's some kind of whole number or negative version of those whole numbers, and the denominator can't be 0. So the reason whole numbers are included in this is because whole numbers can be written as a fraction. 2 can be 2 over 1. The reason decimals are included in this is because decimals can also be written as fractions. For example, 0.7 is the same as 7 tenths. 0.07 is the same as 7 100ths because a 7 is in the tenths spot and a 7 is in the 100ths spot. So this is why all of those are included with rational numbers. But bottom line, rational numbers include integers as well as positive and negative fractions and decimals. So first we're going to graph the number and its opposite. Remember we learned in our last section that opposite just means to change the sign. The opposite of a positive number is its negative version. The opposite of a negative number is its positive version. So the opposite of 3/4 is going to be -3/4. So these are what I'm going to graph, 3/4 and -3/4. Let's put 0 in the middle. And to get to 3/4, I'm going to count by 1/4 for each little segment. So the first is 1/4. The next would be 2/4, but 2/4 can actually be simplified to be 1/2. And the last one would be 3/4. That's where I want 3/4. That's where I'm going to graph my number. And now I'll graph its opposite. So I just need to copy these numbers down, but the negative versions. So -1/4, -1/2. Again, that's the same as -2/4. And -3/4. And that's where we want our other point. 3/4 and -3/4. Next, I'm going to graph -1.6 and its opposite. Again, just change the sign. Its opposite is 1.6 or +1.6. So I'm going to put 0 in the middle. Now to get to 1.6, it seems a little bit odd to think about, but I'm going to actually imagine that I moved the decimal out of 1.6 and that I'm thinking about the number 16 instead. If I think about what I could count by to get to 16s, there's multiple choices, but since I have 4 spots, I'm going to choose to count by 4s, 4, 8, 12, 16. But remember, we removed the decimal, so now I need to put it back into this number. That means I'm going to count by 0.4s. So I could count by 4s to get to 16, so I'm going to count by 0.4s to get to 1.6. So first I have 0.4, then I have 0.8. Next, you might think it's supposed to be 0.12. That does not work because 0.12 is actually smaller than both of these. It has a 1 in the tenths place, whereas these have a 4 and an 8. Let's actually calculate if I add 0.4 more. What would I get? That would be 12. So I would get 1.2. And that makes sense because this 0.8 is only 0.2, 2 tenths away from 1 whole. We still have 2 tenths remaining, so 1.2, 1 and 2 tenths. And then finally 1.6. It's like counting 4, 8, 12, 16, but again, there's a decimal in each one. And that's where we want 1 point at 1.6. Now I'll graph its opposite. So -0.4, -0.8, -1.2, -1.6. And we are done with those two problems. So those are just graphing the numbers and their opposites. Now we're going to actually learn to compare them. So first I'm going to compare -1/2 and -3/4. We're going to do that by graphing them on a number line to see which is further to the right or further to the left. So right now, -1/2 and -3/4 have different denominators, and it's kind of difficult to graph two fractions with different denominators. It's easier if they have the same denominator. One way to get a common denominator is to just multiply the denominators by each other, 2 times 4 and 4 times 2, so that each turns into 8. However, because this denominator is 2, I could simply change this one into a 4, and it would automatically be the same as the other one. So I only have to change one instead of both. So that's a little less work. So let's do that. So I have negative 1/2. I want it to be out of 4. So I'm going to multiply that 2 by 2. And I must do the same to the numerator. So we're just showing that negative 1/2 is the same as negative 2/4. Now that they're both an amount of fourths, I can, on my number line, go count by fourths. So I could put 0, negative 1/4, negative 2/4, which again is the same as negative 1/2, and negative 3/4. So now I can graph my two numbers, negative 3/4 and negative 2/4, and which is greater? Well, negative 2/4, negative 1/2 is greater than negative 3/4 because it is further to the right on my number line. So negative 1/2, negative 2/4 is greater than negative 3/4. And again, we could just do that without a number line. I could compare these two and say, oh, well, negative 2/4 is closer to 0 than negative 3/4 is, so therefore it is greater. Next, I'm going to compare negative 4 and 5/6 and negative 4 and 1/6. I need to add an additional line on my number line. It's just a bit short. And I'm going to go ahead and count by sixths because they both have a denominator of 6. I'm actually going to start at negative 4 and 1/6 and go all the way to negative 4 and 5/6. So next I would have negative 4 and 2/6. But if I simplify 2/6, I could change that into 1/3. If I divide both by 2, I get 1/3. So I'm going to write negative 4 and 1/3. Next, I would have negative 4 and 3/6, but 3/6 can be simplified to be 1/2. If I divide both by 3, I get 1/2. Then I have negative 4 and 4/6. That could be simplified to be 2/3. I divide both by 2, I get 2/3. And finally, negative 4 and 5/6. Now I'm able to graph both numbers, negative 4 and 5/6, negative 4 and 1/6. Negative 4 and 5/6 is less than negative 4 and 1/6. It is further to the left, therefore it is less than. And also, if we just thought about these as which is closer to 0, negative 4 and only 1/6 versus negative 4 and 5/6, this fractional piece is closer to 0, so therefore this entire number is closer to 0 and is the greater negative number. All right, next we're going to do decimals. So I'm going to compare negative 2.3 and negative 1.5. Let's go ahead and plot them on our number line. I'm going to start at negative 1.5 and just count by tenths, by 0.1s. So negative 1.6, negative 1.7, negative 1.8, negative 1.9, negative 2, negative 2.1, negative 2.2, negative 2.3. And now I'm able to graph both of the numbers, negative 2.3 and negative 1.5, and this is showing that negative 2.3 is less than negative 1.5. That is because it is further to the left on my number line. And if I were to compare these without the number line, whenever I compare a decimal number, I just look at each place value. So I would start in the ones place and I would say, well, 1 is closer to 0 than 2 is, therefore negative 1.5 is closer to 0 and is greater than negative 2.3 is. And our last one here, we're going to compare negative 3.08 and negative 3.8. I'm going to start my number line at negative 3 and then just count by tenths again by 0.1s. So negative 3.1, negative 3.2, negative 3.3, negative 3.4, negative 3.5, negative 3.6, negative 3.7, and negative 3.8. So I have a spot for negative 3.8, but you may be wondering, where am I supposed to put negative 3.08? I don't see that anywhere on here. Well, we're actually just going to kind of guesstimate about where it should be, because that will at least tell us if it's further to the right or to the left than negative 3.8 is. So let's back up and review that if I have 0.1, a 1 in the tenths place, this represents 1/10. That means 0.2 is 2/10, 0.3 is 3/10, 0.8 is 8/10, so on and so forth. If I have 0.01, that is 1/100th. 0.01 is 1/100th, 0.02 is 2/100ths, 0.08 is 8/100ths, so on and so forth. Let's also keep in mind, if I have 1/10, how many hundredths is that? That would be 10/100ths. So not only is 0.1 representing 1/10, it can also represent 10/100ths. Not only is 0.8 representing 8/10ths, it can also represent 80/100ths. Now that we know that, let's think about this negative 3.08. Well, 3.08, that 08 part, I can write as 8/100ths. 8/100ths. So I know that this is less than negative 3. It definitely has to be further to the left than negative 3 because I do have this decimal part on the end. But it's only 8/100ths. It's not quite 10/100ths. It's not quite to 0.1. It's just before that because I only have 8/100ths, not 10. I don't have enough to get me to that 0.1, but I'm going to be just before, right about there. That is where my 3.08 should be. That means that negative 3.08 is greater than negative 3.8 because it is further to the right on my number line. It is closer to 0. It's the greater number. We could also have compared these without even using our number line. If I look in their ones place, they both have a 3, so I can't say which is greater yet. But if I look in their tenths place, here's a 0, whereas here's an 8. 0 is closer to 0 than 8 is, therefore this is closer to 0 and is the greater number. Also, 0.08 is 8/100ths, whereas 0.8 is 80/100ths. 8/100ths is closer to 0 than 80/100ths is, so this number is overall greater than the other one. If you feel like you still need some more practice with being able to compare fractions and decimals, like getting common denominators or looking at decimal place value, there are some additional videos posted to Google Classroom under the Chapter 8 preview, so please see that on Google Classroom.